Alright, today is going to be review over functions. We've got first is difference between a linear and a nonlinear function. A linear function is going to be one when I graph and I make a straight line. My rate of change, or the change in my y's, will be constant. So it'll be the same number being added or subtracted over and over again. So with the first problem that we have here, what we can do is find the change in our y. So I'm looking at the change going up here. I should see that it's plus 2 each time. It's important that we realize that our y, or our x's here, are going up by the same amount each time. That needs to happen. So if I have the x's going up by the same amount and the y's going up by the same amount, this is going to be a linear function. And then if I wanted to write an equation with it, I can write it in this way. So I can go y is equal to mx plus b. And so the way that this works out is I can go y is equal to blank x plus blank, where the number in front of the x is going to be my pattern. And then this is going to be my, I call it my starting point. And that is going to be when x is equal to 0. And so if I look at this, right here is my pattern. And then my starting point when x is equal to 0 is going to be this ordered pair 0, 8. So my pattern is going to be a positive 2, and then my starting point is going to be a positive 8. Next one, just given a graph, can I show that it's linear or nonlinear? So I can plot these points. I get 1, 6, 1, 6, 2, 3, 3, 2, and then 6, 1. As I can see, I can't draw a straight line, so I know that this would be not linear. So this one would be not linear because I can't draw a single straight line that goes through all the points. With this one, I can find the range. I can make like a little xy table here. So given my function x squared minus 3, I can go ahead and make an xy chart. And so we've got our xy chart, and I'm going to use -2, -1, 0, 1, and 2. Remember that domain is my x's, and then range is my y's. And so if I'm using -2 through 2 for my domain, I just want to figure out what the y's are. Easiest way to do this is that I can plug this into my graphing calculator. So I can hit here the y equals. I can plug in my equation, which is x squared minus 3. And then I can jump over, I can hit second graph, and that'll take me to my table. And so here I've got my ordered pairs. So my x's are -2 through positive 2, and so these are my y's: 1, -2, -3, -2, and positive 1. So when I want to plug this in, so again, my xy chart, got my -2, -1, 0, 1, and 2, and down my y column will be 1, -2, -3, -2, and positive 1. And so then I can go ahead and plot these ordered pairs. So -2, 1, -1, -2, 0, -3, and then back up. And so here is my parabola using the domain, or x values, of -2 through positive 2. Here I can sort of write a function rule. So Fitness Center charges a $100 sign-up fee plus a monthly cost of $40. Write a function for the total cost C and find the cost of a 4-month membership. One thing that you can do here is sometimes I think it's helpful to, if I struggle with figuring out how to write an equation, what I can do is kind of the same thing we did with the first problem, is I can make a table, and then I can find a pattern and find my starting point. So if I wanted to find a cost, and I can use the months that go by from 0 to 3. So if I sign up for this membership and I am going for 0 months, it's still going to cost me $100. The sign-up fee was $100. I pay that, and even after 0 months have gone by, I still owe that sign-up fee. After I go for 1 month, I owe the sign-up fee and then also $40. So $140. The second month, I would be charged still the $100 fee, so I'd go $180. And then the third month, I would have $220. And so what I can do is I can see that my pattern here is that I'm going up by $40 each time. And then, so this is my pattern, and this is my starting point. And so just like we did, if I wanted to write this in function notation, so C of M, the cost per month is equal to blank x plus blank. My pattern is the 40, and my starting point is the 100. And so then what I can do is I can plug in a 4 for the number of months that have gone by. So I can go 40 times 4 plus 100, and that'll get me $260. Guess I really should have made this and M as my variable for months that go by. And again, if you know how to write the equation just by reading it, then just do that. But if you don't know where to start, sometimes that is something that's helpful is to make a little XY table and then go from there. Here, give the domain and range of the relation and then tell whether it's a function. So the domain, again, like I said, is just your x's, which in this case is 3, 5, and 4. When you have a repeat in your domain and range, you don't have to put it. Your range is your y's, which is -2, -1, 0, and 1. A mapping diagram is going to show what x's go to which y's, so I can make two columns here, one for my x and one for my y. So I have 3, 5, and 4 for my x's, got -2, -1, 0, and 1 for my y's. And so, again, the ordered pair. So I have the ordered pair 3, -2, which tells me that 3 goes to -2. 5, -1 tells me 5 goes to -1. 4 to 0. And then 3 also goes to +1. And so what I have here is whenever I have this happening and x going to two different y's, this one's not going to be a function. The definition of a function is that each x goes to one y. If I have an x going to two different y's, that's going to make it not a function. One thing that can be helpful is a vertical line test. So a vertical line test is just taking a graph, putting a vertical line through it, dragging it from left to right, and finding out if the graph ever touches the vertical line more than once. So with the vertical line test, if it passes through, so if my vertical line passes through more than one point, it's not a function. So with the first one, I'm going to graph the ordered pairs. So I've got -4, +2, -3, -1, 0, -2, -4, -1, and 1, 2. And so, again, what I can do is I can draw a vertical line in each one of these, and as soon as I see one time where it touches it twice, I know this thing's not a function. So not a function. With this second one, again, I can do the same thing. If I have it there, it only touches it once. There, only once. There, only once. There, only once. And so this one, since it only touches it once all the way from left to right, this one is going to be a function. Yes, it's a function. And then the last one, again, I can just pick a point on here. It should be pretty easy to see that when I do it right there, I'm going to get it to touch 3 different times. So this one is not a function. Remember that it has to go all the way from left to right for it to be a function one time. All it takes is just one time where my vertical line touches it more than once for it not to be a function. And the last one, being able to evaluate a function with domain and range. And so this is something that on the air test there have been multiple problems with. So if I have these as my x values, this is the way that we want to write it. So this function right here, f of x is equal to 3x plus 2 is just naming the function f and saying that x is going to be our input. So when I plug in a negative 5, I'm going to write it as, f of negative 5. So my function f when x is negative 5 is equal to 3 times negative 5 plus 2. And then what I want to do is I want to go ahead and actually do that calculation. And so I do 3 times negative 5 plus 2, and that gets me negative 13. And that should be the way that our final answer looks. F of negative 5 is equal to negative 13. You don't have to solve for f or anything. That's my final answer. Same thing. F of 2 is equal to 3 times 2 plus 2. So I get f of 2 is equal to 8. That's my answer there. F of 7 is equal to 3 times 7 plus 2. I get f of 7 is equal to 23. Again, that's my final answer. The last one, f of 12 is equal to 3 times 12 plus 2. And so f of 12 is equal to 38. Final answer. And so if I wanted to list my range are my outputs are my y values. And so I can list it as negative 13, 8, 23, and 38.